we have traditionally set education up as a drudgery, but when you set it up to where it's a challenge and you set no parameters, you let them go their own direction, this is how learning really takes place, as opposed to the contrived school setting. The concept that we're working on here to use the FarmBot goes multi-generational, if you will. So we would be looking to engage K-12 students. They would be addressing real research questions that we are trying to address, but to them it's a project they've been tasked with, and they might not have all of the answers. So we dovetail that with undergraduate students, which there's a large movement at our university towards involving them in real research, because we want them to have that mindset. So they partner up with these students so they can contribute other in-depth knowledge, etc. But then you would also partner them up with the graduate students, the doc students. So you have this, who then are working with the faculty at both the university and the K-12. So this full circle. So the curricula at the K-12 is influenced by what the students are doing. It's really the students are determining what the curricula can benefit from. Within education, you primarily are within four walls. It's you alone, typically. I think from a university standpoint, they espouse collaboration and they reward individual. But there's a growing trend towards, even at national funding levels, that the results of your research, et cetera, have to be disseminated. They have to be open and accessible too, because they recognize that that's a very important component of this. And so you develop tomorrow's not only problem solvers, but you are developing what they're looking at as a STEM workforce for tomorrow, but with a very different concept. It's an open source kind of concept. If I were to utilize and incorporate a FarmBot into the curricula, into a school system, utilization of the FarmBot would be driven by the research question. And there'd be multiple questions, and there could be questions in multiple areas. So you might have a question that was specifically science. You might have a question that was more for programming. You might have a question that's more for technology. You might have a question that more for production, harvesting. And I would look at those and recognize where within my curriculum they were being addressed. And then in the process of the student addressing those research questions, they would probably not be able to do it all on their own, so they would have to collaborate with the people around them. The challenge for the educator is to make sure you're orchestrating that so that you're fairly certain of what the student is going to be confronted with for what a need to know, so that they're going to be addressing the morphology of the plant or nutrients, or they might be doing this grade appropriate math in order to calculate the load or whatever the case may be. The benefit for the student is they see the results of their work. And if it doesn't work right, failures are great things for learning. And so what they do is, why didn't it work? And so they troubleshoot. The troubleshooting is something also that it's not something that's well developed within an educational setting. You either get the answer or you don't. If you don't get it, okay, well, here's how you should have solved it, show all your work. The learning really takes place when they have to go back and figure out why it did not work. What is it that I have to do better or different? This FarmBot presents that kind of an opportunity on a basis that the student almost willingly continues because it's a challenge to them. But I think also another part that's not easily addressed in your traditional, math class, science class, etc., is the development of tool sense and the development of tacit knowledge. So I can think of something conceptually, or I can do it in a CAD program, and I can make it run. It works perfectly. And then I say, now build that. And it doesn't work. Because they had never developed the tacit knowledge to know that what they were designing, the way it looked like it was working in the animation, doesn't really work. So this is an opportunity where they can take that kind of a concept, where they might design a piece or whatever and then try to put it in place, and it doesn't work the way they thought it was going to work. And then they have to physically manipulate it and work it, which gives them tool sense. Which tool do I use? Is it the screwdriver? Is it the wrench? Is it the, whatever it might be, a large motor, small motor? And then they begin to understand from a tacit standpoint how the conceptual piece works in the material world. The documentation of it, the being able to go back and to recognizing mistakes are not bad things, that they are beneficial. I mean, you don't want to make mistakes, but you're going to, and they're beneficial in what they tell you, what you learn from them. FarmBot provides that opportunity over and over again, and in multiple different ways and multiple different content areas. The student attraction to FarmBot and their interest in it, as the educator, what you want to do is situate this particular instructional tool within the real context. So what is it that FarmBot allows us to address from a global scale? So you could go back to the engineering challenges and clean water, environments, etc. And so you connect it to that, and then you connect it, and how are those directly related to what's going on outside our school in your community? So you can do that by local video clips, people coming in to talk. In other words, you're developing the context, which is a real, authentic context, and relating it directly to the learner. And then you're saying, here is part of how we can address solutions to these issues. And so you build that context for the students, you have relevance for the student, and then they take ownership of it. And once they have ownership, they will go forever